Hello everyone. Now today we're going to talk about the laws of exponents, part 1. So first thing we have to do is we have to learn about the anatomy of a radical, or an exponent, exponent. We have the base, that is our large number. We have the exponent, also called a power. And the rule basically says is that we're going to multiply the base by itself the exponent number of times. So in our example, if I have b to the xth power, that says we're going to multiply b times itself x amount of times. Okay, pretty easy stuff. Now, here's where it gets tricky when we're talking about the laws of exponents. Now, if we take common base a, that's this guy right here, and I raise it to the first power, then we wind up with the number itself. So, for instance, if I add 4 to the first, it would just be 4. If I had 1/2 to the first power, it would still be 1/2, and so on and so forth. If I added x to the first, it would just be x. Okay, pretty easy. Now this next one gets a little tricky. Any base raised to the 0th power is automatically 1. Now the only explanation I have for this that makes any sense goes back to ancient mathematics. Now, in today's times, when we multiply, let's say 3 times 2, we just multiply it as 3 times 2 and get 6. But back in ancient times when they used to do this, they would do 1 times 3 times 2, which gives us 6. And the reason why they multiplied by 1 is because that means they thought that if you start with a base of 1, you shouldn't get 0 as an answer unless you multiplied with a 0. So again, that thought it continued when they started introducing exponents. So like 2 cubed meant 1 times 2 times 2 times 2. So you do 1 times 2, which is 2, times that by 2, you get 4, times that by 2, you get 8. So when they introduce something like 3 to the 0, well, you'd start with 1, but then this says you would take 3 and multiply it by itself no times, leaving just 1 as the answer. So it's the only rational explanation I have that makes any sense to anyone, so we'll go with that. Alright, the next rule. If I take common base a to the mth times common base a to the nth, I add the exponents. So if I take x cubed and I times that by x squared. Now if I break this down even further, x cubed means I have 3 x's being multiplied together. And x squared means I have 2 x's together. So if I put this all together, I have 5 x's, or x to the 5th. Or if I go here, using our rule, x to the 3 plus 2 power is x to the 5th. Okay? Our next rule, if I take common base a to the mth and I raise it to the nth, I multiply. So if I take x squared and raise that to the 4th power, okay? Now, this 4 on the outside here says I'm going to take this base and do it by itself 4 times. So x squared times x squared times x squared times x squared. And if you want to break that down further, again, you don't have to do this. I'm just doing this so people can see what these rules are doing. So it looks like this, and then we put it all together. Well, how many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8, or x to the 8th. Here, in this set, we can use the rule we just did, and since they're all in the same level, we're going to add the exponents. So 2 plus 2 is 4, plus 2 is 6, plus 2 is x to the 8th. Or using our new law, if I do x to the 2 times 4, it's also x to the 8th. So a couple different ways to demonstrate this law. Alright, this one starts to get a little trickier. If I take common base a to the mth, which is then multiplied with common base b to the nth, then I'm taking the exponents and raising it to this power. I multiply those exponents together. It's similar to the last law that we saw, only I've introduced a new base inside of the parentheses. So we start. For an example, let's do x cubed y squared being cubed. Okay? So again, this says I'm going to take the base in here and take it to the third power. So we have x cubed y squared. X cubed y squared. X cubed y squared. Okay? Then from there, if I want to break this down even further, x cubed is 3x's. Y squared is 2y's. 3, 1, 2. 1, 2, 3. Whoops. There we go. And 1, 2. So if I pull this all together, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So x to the 9th. 2, 4, 6 y's. So y to the 6th. Now again, if I use my adding rule, okay.
Gee, let me just tell you. Should I take it back?
No, just
So again, 3x's here, another 3x's here, another 3x's. So 3 plus 3 is 6, plus 3 is 9, so x to the 9th. Then y squared, and y squared. 2 plus 2 is 4, plus 2 is 6. Or using our new rule, I can say this is x to the 3 times 3 and y to the 2 times 3. Well, 3 times 3 is 9 and 2 times 3 is 6. Look at that. All nice and neat. Alright, our next rule is really tricky. It starts here. If I have common base a to the nth plus common base b to the nth, and I raise that to the tth power, the difference between the other ones and this is a plus or minus. Now remember, when there's a plus or minus between the pieces, that means that these are all put together as one chunk. So that whole thing is your base.
That guy is making me get a pass.
So you can't just go power to power. So unfortunately, what you have to do is do it out the long way, where you take the base and multiply it by itself the exponent number of times. Alright, now when we deal with fractions, okay, if I have common base a to the nth over common base b to the nth, or you may see it more like this, and you raise it to the tth. Okay, again, we're still going power to power here, but we're going to multiply the exponents though. So a to the mt, b to the nt. Okay, or let's say I have x cubed all over y squared being raised to the 4th power. Now applying our rules, this will be x to the 12th. Y squared to the 4th is y to the 8th. Pretty easy. Now, here's the biggest part. One of the biggest things we have to remember is regular numbers get treated regularly. So if our function is dealing with multiply, we multiply. If it's dividing, we divide. So if we're dividing, etc., etc. So for instance, if I had something like 3x and I times that by 2x squared, a common misconception is that when it looks like this, that I'm just going to take this and add it to this, because when I take x to the first and do it with x squared, I do get x cubed. Because when they're here, we would add them. But people sometimes don't understand that this is still regular numbers, so they get multiplied regularly. So 3 times 2 is 6. Now, or if we have this, 2x squared being cubed. Okay, another classic mistake with this is, yes, with the exponents we multiply according to our rule. So that would give me x to the 6th. But people then see this and go, well, 2 to the 3rd, so that's just 2 times 3 or 6, which it's not. Remember, this is a regular number, so we're going to treat it as a regular 2 cubed, or 2 times 2 times 2. And then people say, well, gee, that's still 6. No, it really isn't. Because 2 times 2 is 4, then 4 times 2 is 8. So you've got to be careful. Okay? This rule has one exception. It's unless the regular number has an exponent, then we treat it like a variable. So let me show you what I mean. So let me give us some room here. So I'll scooch down a little bit. Okay? Now, let's say I have 2 squared x to the third being raised to the second power. Okay? Now, a classic mistake is with this. Power to power says we multiply, so it's x to the sixth. Power to power, that should be to the fourth, and that's true. And then you guys do this. Well, 2 squared is 4, so then you have something like this. And this is where we go wrong. Anytime the base has an exponent, like this guy here did, we're going to ignore this. We're going to just do it like this. So we have 2.
Talking to yourself?
So, here we go. So let's evaluate this now. 2 to the fourth is 16, x to the sixth. So be careful. Alright, so let's take a look at our first example. Alright. Now again, notice I don't have any exponents here on the outside, so I don't have to worry about that. So we're just going to put like things together. So remember, regular numbers get treated regularly. So 3 times 5 is 15. X cubed means I have 3 x's here. X to the sixth means I have 6 x's here. So using this rule, rule number 3, I'm going to just add the exponents together. So 3 x's and 6 x's make 9. Okay, let's go to the y's. Y to the fifth, y to the fourth. 5 y's here, 4 y's here is y to the ninth. Now here's where you really got to be careful. The z's. Okay, let me get rid of this. Whoops. Let's get rid of this. Okay, now remember this z has a 1 here because you can't see it. So I have 2 z's here, I have 1 z here, so this is z cubed. Done. Alright, let's look at this next one. Okay, now again, regular numbers get treated regularly, and I'm going to a power. So this says it's 2 to the fourth. And 2 to the fourth is 2 times 2 times 2 times 2, or 16. Now, x to the sixth to the fourth. Power to power says we multiply, so that's rule number 4. So 6 times 4 is x to the 24th. Y cubed to the fourth, 3 times 4 is 12. And 4 to the fourth is z 16. Done. Piece of cake. Alright, now here's where it gets different, because notice my regular number has an exponent. So we're going to ignore the regular number, we're going to keep it as 2. Now 2 times 3 using this law right here, so this is going to become 2 to the sixth. X to the sixth cubed is x to the 18th. Y to the first cubed is y cubed. And z to the seventh cubed is z to the 21st. Now, one last thing we have to do, we have to evaluate this. And 2 to the sixth is 64. X to the 18th, y to the third, z to the 21st. And there it is. Alright, now here's where it gets more fun, because we have multiple things going on here. So let's start. Evaluate this stuff first. 2 squared is 4. X cubed squared is x to the sixth. Y squared squared is y to the fourth. Z squared squared is z to the fourth. Okay. Now here, 3 squared is 9. X squared squared is x to the fourth. Y being squared is y squared. Z to the fourth squared is z to the eighth. Now, here's where now we're going to be very careful. We're multiplying here. So regular numbers get treated regularly. So 4 times 9 is 36. Now here's where we're going to apply law number 3. Okay, because they're on the same level here. We're just multiplying, so we're going to add. So if there's 6 x's here and 4 x's here, that means there's 10 in total. 4 y's here, 2 y's here is y to the 6th. 4 z's here, 8 z's here are 12 z's. Done. Alright, now here we got a fraction, so let me rewrite this because again, it's hard to put fractions in on this thing. Okay, so I have 3x cubed y squared z squared divided by 2 being squared times 6x squared yz all over 1. Alright, so let's start by squaring. 3 squared, 9. X cubed squared is x to the 6th. Y squared squared is y to the 4th. Z squared squared is z to the 4th. Now I have to do the bottom, so 2 squared is 4. And here, oh, I knew I forgot the square on the outside on that one. Alright, so 6 squared, 36. X squared squared is x to the 4th. Y being squared is y squared. Z being squared is z squared. And 1 squared is 1. Now remember, since we're multiplying fractions, I can reduce up and down and diagonally. So this 36 and the 4, I can reduce. I'm going to cancel that off. I can make this a 9. Okay, so now I'm going to scooch this down a little bit. Alright, so let's put this all together. So 9 times 9, 81. X to the 6th and x to the 4th is x to the 10th. We're adding. Y to the 4th, y squared is y to the 6th. Z to the 4th and z squared is z to the 6th. And on the bottom, we have 1 and 1, which is just 1. Now again, you can leave it like that, or just realize, since there's 1 in the denominator here, I really don't need that anymore. So you can leave it like that. Alright, now let's really have some fun. Alright, so if you want to work ahead of me, you can. And we're just going to fix this fraction here. So I have 1x, y, z all over 2. Okay, 3x squared, y squared all over 1 being squared. So it's 4x, y cubed, z squared all over 1 being squared. Alright, so I'm going to start here. Hopefully you've worked ahead of me a little bit. 4 squared is 16. X being squared is x squared. Y cubed squared is y to the 6th. Z squared squared is z to the 4th. Over 1 squared is 1. Okay, here, 3 squared, 9. X squared squared is x to the 4th. Y squared squared is y to the 4th. 1 squared is 1. Alright, here we go. 1 cubed is 1. X being cubed is x cubed. Y being cubed is y cubed. Z being cubed is z cubed. All over 2 cubed is 8. Alright, scooch down a little bit so I have more room to work. Okay, now I can start canceling things. Like the 8 and the 16. I can cancel that off. I can make this a 2. Alright, so let's put this all together. Regular numbers, 2 times 9 is 18. 18 times 1 is 18. X squared, x to the 4th, x cubed. So we're going to add these. So 2 plus 4 is 6. 6 plus 3 is 9. Y to the 6th, y to the 4th, and y cubed. 6 plus 4 is 10. 10 and 3 is 13. And z to the 4th with z cubed is z to the 7th. All over, and on the bottom we have 1 times 1 times 1, which is 1. So again, you can leave it like that, or realize that we don't need this anymore. So there it is. Alright, let's really have some fun on this one. Now be careful. One thing you should note, that negative here really means -1. So I'm going to fill it in to remind myself that it is there. Okay? Alright, so here we go. Power to power. 4 cubed, 64. X cubed is x to the 9th. Y to the 4th cubed is y to the 12th. Z squared cubed is z to the 6th. Here.
No,
-1
exactly.
cubed. Now that means -1 times -1 times -1, which is still -1. X to the 4th cubed is x to the 12th. Y to the 5th cubed is y 15.
His room, if that's all right.
Z cubed is z to the
Bell
9th.
rings, what, in about 4 minutes?
Now here, nicely enough for us, all this is being raised to the 0th power, which really means all this gets turned to 1. All that for that. Alright, so now that's our next step. Regular numbers put together normally. So 64 times -1 times 1, -64. X to the 9th and x to the 12th, we're adding, so x 21. Y to the 12th, y 15 is y to the 27th. Z to the 6th and z to the 9th is z 15. Done. Alright, so that's pretty much it for this. So hopefully you learned something. Go out there, give these a few practice tries, and we'll see you in the next video.